Okay, so this review is going to help you with the functions and limits section. So we're just going to take this 1 to 100 packet and do all the functions and the limits. So the first one is number 4. It says the table below represents the size in acres of the average farm. It's got years, it's got the acres. Choose which mathematical model below best fits the data. Use the model, predict the appropriate size of an average farm in the year 2010. If you look at our 4 choices, we have 2 that are linear and 2 that are quadratic. So the first thing we have to do is figure out if we're linear or if we're quadratic. You cannot look at the table and guess. What you have to do is type your data into your L1, L2, and then calc. I'm going to go down to number 4 and do a linear regression. And what I'm looking for is my R. Okay. Now again, I'm not looking at my R squared. I'm looking at my R. So his R is a 0.928. And that's for linear. And then if I wanted to do quadratic, that's number 5. And that one doesn't have an R, but it gives me an R squared, so I can square root that. So 0.99713. So if I square root 0.99713, I get 0.998, and that's for quadratic. So quadratic wins. So these 2 are out. Now what I've got to do is I've got to get the equation so I can predict. So I got to go back and get my equation. So you can see it's y equals ax squared plus bx plus c. It tells me what my a is, and my b is, and my c is. And I don't know if y'all remember doing this one in class, but the farther out we went with our decimals, the better off we are. Because if you look at choice C and D, 360 and 400 are relatively close together. So we want to go far with our decimals so we can tell which one it is. So you're gonna do your y equals, and then whatever your a is, plus whatever your b is, plus whatever your c is. And then I'm going to take 2010 and I'm going to plug it in there. So on my home screen, I'm going to type negative 0.127573, as far as you want to go, times 2010 squared plus, now the b value, 508 point, all those decimals, times 2010, and then plus my c, which is negative 506053 point blah, 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 blah. Hit enter, and I got 400 on the button. Okay, so again, this not so much about math, but just about knowing what your calculator can do for you. Okay, the next one we're going to go to is number 6. This is a piecewise function. This one actually turns out to be really easy. If you'll just look at which function is which and the open and the closed, you can tell that these 2 don't have an equal to, and these 2 do. So just on that alone, if I look at my linear line, I can see that it ends on an open circle. So I know that I don't want, for the linear part, I don't want it to have the equal to, because I have an open circle here. So he's out and he's out. Okay, then if I look at my second interval, they look to be the same. And my third interval, they look to be the same. So now let's look at the actual functions. So if I come back and look at all these, all they are the same. If I look at him, and him, they are the same. But if you look at the third one, they're different. So right here's where I can pick my answer. You've got to remember your shifts. If it's outside the function, it's up, down, true to the sign. So this would be a down one. If it's inside the function, it's right, left, opposite the sign, unless it's funky. And this one's not funky. So this is a right one. Now look at your graph. I know this is the swoosh. He's definitely down one. So I want this one. When the answers are this close, find the subtle differences and just be logical about what you want. Okay, so that was number 6. Now we're going to go to number 7, which is another graph. Okay, so it's another piecewise function. It wants the range. You need to know that range is y, domain is x, range is y. And it wants the range. So basically, I need to graph this thing. And you will be provided graph paper on the exam, so you can graph it. So my first one is y equals x minus 4, but I only want it for the x's from 0 to 2, including 0 and not including 2. So I know this is linear. He's going to go down 4, and then he's going to go up 1, right 1. So he's going to do this. So that's him. The problem is I don't want all of him. I only want him for the x's. Now x's, that's right, left, from 0 to 2. And at 2, I want to be an open circle. So I only want that piece of it. Okay, this is a quadratic that's a little bit more in-depth to graph, so I'm going to skip him and go to this guy. He's y equals 5. That's a horizontal line at 5. And I want it for the x's from 4 to 7. So I'm going to go up to 5. 1, 2, 3, 4, 5. He would look like this. But I only want it for the x's from 4 to 7. So there. 5, 6, 7. To there. And I'm going to be closed on 4, open on 7. Okay, now I can do the parabola. Now I know that the quadratic function looks like a parabola, but I got to be more specific in my details. It's not in parabola form, so I can't tell the shifts. But I'm just from 2 to 4. So I'm just going to plug in a 2 and plug in a 4. What you can do is go to your calculator and plug him in, and I'll show you how to do this. Plug him in, and then just go to your table and look from 2 to 4 and see what his points are. So let's try that. So I'm going to go to my y equals. I'm going to type this guy in. I'm not going to my graph. I'm going to my table. And again, I only wanted him from 2 to 4. So at 2, we're at 2. 3, we're at 4. And at 4, we're at 8. So 2, 4, 8. No. Yeah, 2, 4, 8. So at 2, we're at 2. At 3, we're at 4. And at 4, 5, 6, 7, 8. Open circle at that one. I know he's kind of a parabola. Okay, so there's the graph of this piecewise function. That was a great review for that. Again, I want the range. Now the range is from low to high. And then you have to choose your brackets and your parentheses. So how low do we go? We come all the way down here, and that's at -4. And how high do we go? We go all the way to 8. The problem is we're not everything in between. There's a gap. There's a gap right here. We will never be these y's. So this one is from -4 to -2. I can be -4, but I'm an open circle at -2, so I can't be that one. Then it picks back up at 2 with a bracket, because I can be 2, and goes all the way up to 8, but I can't be 8. So that's D. All right, now we're going to head over to number 11. And I'm trying to go slow enough to where this really sinks in, where it's beneficial, but fast enough to where we can cover some stuff. So if I go over a problem that doesn't sit well with you, just rewind it and listen to it again. Okay, zeros. You need to know that zeros are solutions. You need to know that to find solutions, you're just going to set this equal to 0 and solve it. If I set this equal to 0 and I multiply both sides by the bottom's gone. I'm not interested in the bottom. I'm not finding asymptotes. That's not what this is about. Zeros are solutions. Solutions, you set the problem equal to 0. When I do that and I multiply both sides by the bottom, to get the bottom out of the bottom, it's going to cancel. And then the bottom times the 0 over here is going to still give me 0. And then I just factor. Factors of 3 that subtract to give you 2 are 3 and 1. Signs are different. Bigger one's negative. So when I solve this, I get a 3 and a negative 1. Now what you do need to be careful about is that you can't keep solutions that would make the denominator 0. So if I factor the bottom, 14 that subtracts to 5, that's 7 and 2. I want a positive 5. So positive 7 and a negative 2. I'm safe with a 3 and a negative 1. Neither one of those are going to make the bottom 0. Okay, now we're headed to number 15. The surface area of a balloon can be represented by that thing where r is the radius. R increases with time t, and the radius, changing with time, is represented by this function. There's the surface area. What is the surface area as a function of time? See, right now the surface area is a function of r because it has r's in it. Well, I want the surface area as a function of time. I want the surface area formula that has t's in it. So what I need to do is replace my r, that guy right there. Well, this is the formula for r. So what I'm going to do is I'm going to replace r with this stuff right here. So I'm going to have s, it's actually going to be s of t, 4 pi, and then this was r squared, so now here's where I put this in. So I just replaced the r with that piece right there, and now I just clean it up. And this was 2 times 2 to get this 4, not 2 plus 2. And then 4 over 16 would be 1/4 pi t to the 4th. Okay, that was 15. Now we are headed to 17. In 17, I feel like now it has finally clicked. This is a piecewise function. I want it to be continuous. Continuous means the two pieces of the piecewise function have to meet. So I need this to meet this. So that's a pretty logical explanation. Now, where do they break? They break at 3. So I need them to equal each other at 3 when x equals 3. So I'm going to plug in a 3 for all my x's. That's a negative 18. That would be a negative 3. That would be a 7. And then subtract 6. And divide by 3, that would give me 1/3. All right, headed to number 24. This is a really good, just straightforward inverse. And it does want you to find the inverse at negative 3. So the first thing I'm going to write what I was given. To find the inverse, you do 2 things. You switch the x's and the y's, and you solve for y. So I'm going to switch my x's and my y's, and I'm going to solve for y. So I'm going to add 9. I'm going to multiply both sides by 3. So it gives me 3x plus 27 equals 4y, and then I'm going to divide by 4. Okay, so that's the inverse. Now I want the inverse at negative 3. So 3 times negative 3 would be negative 9 plus 27 over 4. And negative 9 plus 27 would be a positive 18 over 4, which reduces to 9 over 2, so 4.5. And you can do that on your calculator if you want to. If you type this into your calculator, please make sure that you know that you have to do negative 9 plus 27 and then hit enter and then divide it by 4. If you do this, that only divides the 27 by 4. You could do parentheses, or you could just do this, hit enter and get your 18 and then divide it by 4. All right, that gets us 24. Now we're going to 30. What transformations have occurred to create that function from the parent function of just an x cubed? Well, you know the minus 4, and you can see that it is outside the function, because inside the function would have to be inside that cube. So that's a down 4. So up and up are going to be no. Down and down are what I want. So down 4, I like both of these. Both of these are down 4. The 3 out front is going to make it rise faster, so it's going to be a vertical stretch. So D. A vertical shrink would be like a 1/3. Watch out for things like a 5/2. That would still be a vertical stretch because that number is bigger than 1. Anything that's bigger than 1 is going to be a vertical stretch. And anything smaller than 1 is going to be a vertical shrink. Now notice they put stretched horizontally, but remember that a stretch horizontally is a vertical shrink. Because if you squish it, it's going to get wider. So, okay, that's number 30. Now we're headed to number 33. Okay, these are very simple, but in going over these, we missed these, and they were just silly little careless mistakes. So slow down and be careful. Get these right. First, I got to do t of 3. So that would be a negative 3. Now I'll take my negative 3 and I plug it into p. So that would be negative 30 plus 2. That's a negative 28. So all of this is a negative 28. Then I have this minus sign that I'm going to go ahead and bring down. Now I'm going to do p of 3. That would be 30 plus 2. That's a 32. And now I'm going to plug it into t, so that's a negative 32. And because I have the minus minus, I'm going to plus plus and get a positive 4. Just watch your signs. Okay, now we're going to number 36. Okay, distance between the y-intercepts of this graph. Okay, and some of you got really good at knowing he's a y squared, so he's going to be an x equals. Like, y'all were good at that. You know you need to move the 8 over. So we're here. And the problem is my calculator isn't x equals. I have a y equals button. But what you can do is plug him in and go check out his graph. Hold on. Go check out his graph because these x-intercepts are going to be the y-intercepts that I want. It's just turned the wrong way. So I've got an intercept at -1 and one at -5. And then I just need to know the distance between those two, and it's 4. The next one we're going to do is number 37. Okay, solutions. So I'm solving it. And I can already see some of these have one answer and some of them have 2. I can already tell that I can't be 1. So I know he's out because 1 would make the bottom 0. When these are equals like this, when you see an equals, you get a common denominator and then you drop it. So I'm going to put him over 1. I'm going to give him an x minus 1. So that would be x squared minus x plus 3x equals x plus 2 because the other guys are good. He is quadratic, so I need to get him equal to 0. So I'm going to move the x and move the 2. So we're equal to 0. So I have x squared plus x minus 2. If I combine all of those, and then my minus 2 equals 0. And then I factor it very carefully. 2 and 1. I want a positive 1, so I want a positive 2 and a negative 1. And then I solve that. I get a negative 2 and a positive 1. We already talked about the fact that I can't be a 1 because it would make the denominator 0. So the only answer I get to keep is my negative 2. Okay. So that was 37. Now we're headed to number 42. Okay, and this is the cardboard box. Which, yeah, it's difficult, but gosh, you can totally do this. James has a rectangular piece of cardboard that was 4 times as long as it was wide. 4 times the width. There's my width. I'm cutting out a 3-inch corner. So if I'm doing this on both sides, this length that was 4W, it's getting this cut out of it. So I'm now 4W minus 6. And this length right here that was W is now getting 3 on either side cut out, so we are now W minus 6. Okay, now it gave me the area, or the volume. Volume is 336. Guys, you got to know that volume is length times width times height. So my volume is length, 4W minus 6, times width, W minus 6, times height. Now think about this like a shirt box. Like you were wrapping a Christmas present. You put it in a shirt box. This is the part that gets turned up. So that's your 3. That's your height. Now, I don't have to set it equal to V because I know what my volume is. It was 336. Now it wants the original width. Well, that's great because I got a bunch of W's in here. So when I solve this, I'm going to find the width. And you can do this really easy on your calculator. Now, there are 2 ways you can do this. There's the long way and the short way. The long way I'm going to go ahead and subtract my 336 over. Is 2 lobster. Get that answer. Then take the 3, distribute it all the way through, and then subtract your 336 and clean it up and make it all pretty. But guys, your calculator could care less if it's pretty or not. It just needs you to type it in correctly. So instead of doing all that, this is what I'm going to do. Now I am going to move my 3 to the front just because he's little and I'm worried he's going to get lost. Okay, guys, I'm going to type this in to my y equals. I'm not going to clean it up at all. So when I go y equals, I'm going 3 times 4x minus 6 times x minus 6 minus my 336. Okay. Now I can go to my graph and I can see, okay, it crosses 2 places. It crosses at a negative 2. Okay, well think about what you're solving for. You're solving for W. It does not make sense that your W is negative. So I'm going to ignore him. The other one is somewhere in between 9 and 10. I'll look at my answers. There's a 9.5. And again, I have the letter W, so when I solve this, I'm getting W. And it doesn't want the W minus 6. It says what was the width of the sheet of cardboard that he started with. So the whole thing. If it wanted the width of the box, then I would subtract 6 from that. Because remember, we took 3 off at each corner. Okay, now we're headed to 44. Okay, this is another inverse. I don't need any of this information. I just need to know inverse. So I have y equals 2.5x plus 1 over x. I'm going to switch. Okay, I'm going to multiply both sides by y to get him out of the bottom. So I have xy equals 2.5y plus 1. And this is where most of us got stuck. If you're solving for y and you have 2 terms that have a y, and you can't add them together because they're not like terms, get them on the same side of the problem. And then GCF the y out. And there's my y. So now all I got to do is divide by so y equals 1 over x minus 2.5. There you go. All right, let's see. We need to go back and do 44. An object is launched straight upward from the ground level with an initial velocity of 50 feet per second. It gives me the equation. At approximately what value of t will the object have a height of 28 feet and be traveling downward? Okay, now we have an object launched straight up, comes back down. It's going to hit 28 feet twice, once on the way up and once on the way down. I want this one. This is my time. So what I'm going to do is I'm going to type this sucker. I'm not going to set them equal to anything. I'm just going to type the object's formula. I'm going to go to my table. Now it hits the ground somewhere in between 3 seconds and 4 seconds. How far do my answer? My answers go 2 decimal places. So I'm going to go table, and I'm going to go up by 0.01. That'll get me 2 decimal places. Now, if I do this, I'm going to sit here forever scrolling, and I haven't even hit 28 seconds on the way up yet. So I'm going to go back to my table start, and I'm going to say, let's start at 3 seconds, and let's see what's going on. Okay, at 3 seconds, I've already started coming back down. So let me go back up. I'm trying to find 28. Here we are. Yep. Somewhere in the 2.3-ish. So A. Now look, it hits 28 seconds. Earlier. Goodness. All right, it's starting to come back down. So this was its original. At 1 second, it's already hit 28. So somewhere around 0.7, and then look at that. They know you're going to pick that. But that's here. That's when it's on its way up. I want the one on its way down. So I want this one. So just be careful. That's not a math mistake. That's a reading mistake. So just slow down. Okay, now we're going to 45. Range, again, you got to know that range is y. If you don't know what he looks like, then you're going to type him into your calculator. I'm going to just go off of shifts. I'm going to put this guy in the back because it looks more normal. I know that we're going to go down 5 and left 3. I also know that we're opening down. So my range is low to high, always. Well, low, it goes all the way down to infinity. High, it doesn't get any higher than a -5. Now, does it get to be -5? Yes. Okay, now we're going to go to number 50. 50 was one of those pretty straightforward, logical kind of problems. We're going to return it 15 days late. They're going to charge me $50 just to get it. And then day 1 through 10, so that's 10 days of $5. I'm going 15 days late. 11 through 20, but I'm only going to day 15. So 11, 12, 13, 14, 15. That's 5 days at $8. That gives me 140 bucks. The next one we're going to look at is number 56. And it's a limit. But again, we're missing this one, and it's just because you guys aren't super familiar with what your calculator can do for you. I want the limit as n heads to infinity of some crazy exponential function. Guys, you have a table that will take you to infinity, or, I mean, it'll head towards infinity. So what I'm going to do is I'm going to type this sucker in very carefully with parentheses. And then I'm going to go to my table. Well, I got to change it from before. I'm going to start at 0, and I'm going to go up by, I don't know, 10, because I'm headed towards infinity. So I'd like to, you know, get an idea. Well, there you go. I mean, where are we headed, guys? It's a 1. Easy. Okay, that was 56. Now we're headed to 57. And again, this is another one that I feel like we're good with now. I want the limit as x approaches 2. Guys, you know that the only way the limit exists is if it's headed to the same place from the right and from the left. So I need that piece to equal this piece at x equals 2. So I'm going to plug in a 2. So that's 2c plus 1 equals 4c minus 1. I'm going to subtract my 2c and add my 1. So I got c to be 1. 57. Okay, now we're headed to 62, which is just a really easy, straightforward shift. Okay, and this, so a lot of us missed this one on one of the quizzes that we did. This is my parent function, just y equals x squared. Don't worry about the a. I want to shift up 3. Well, you know that means a plus 3 on the end. And I want to go right 5. And this is what a lot of you gave me. Just because you put parentheses around this does not make it inside the function. The function is x squared. To make it inside the function, that minus 5 to go right 5 has to be inside the square. It has to be inside the function. You do great when it's multiple choice, but writing it out, just be super careful. So this one was A. All right, that was 62. Now we're headed to 73. And this one is another limits. And super easy if you know what your calculator can do for you. It wants the limit, and we're headed to infinity and negative infinity. So I am going to grab my calculator, and I'm going to plug this guy in. I do not need parentheses around the top because it's only one term. Okay, watch your parentheses, and that's not an 11, that's a 1. 1 plus point. Okay. So now I'm going to go to my table. Okay, well, I'm headed to positive infinity, and it looks like we're obviously headed to a 100. So positive infinity, which are these guys over here, headed to 100. So he's out and he's out. I like both of these. Now let's turn around and head back to negative infinity. I'm going to change my table set and just go back and start at 0 and go to my table, and I'm going to jump this way. Okay, now you have to make sure that you know what those e's mean. Like, so the one that I'm on, that would be 2 times 10 to the negative 29th. That's point. 28 O's and then a 2. So we're getting super, super, super close to 0 or 1. Super close to 0. All right, that was 73. Now we're headed to 75, which is another good limit. It says in the piecewise function below, k is a constant. What is the value of the limit as x approaches k from the left of f of x? Okay, this is the main stage. This is just plugging the hole. I don't care where the hole is when we're talking about a limit. It's not where is it at k. It is here at k. I'm not interested in that. I'm interested in where is it approaching. So I'm interested in this top guy. The problem with this, and normally we approach a number, and here they've got us approaching a letter, which is a little odd, but you know, whatever. If I plug a k in for my x, I get k minus k, which is 0, which makes the world stop turning, and that's bad. So I can't just straight up plug a k in. So that's when you say, okay, I've got resources available to me. I need to be able to figure out how to manipulate this so the world doesn't stop turning. If you look at the top, these are squares, and you can factor those. And when you do that, those cancel, and that's the problem. So now that my problem is gone, I reset my limit and do it again. So if I plug k in for x, I get 2k. All right, now we're headed to 77. You've got to know your asymptote rules. Have to, have to, have to. Vertical, you set the bottom equal to 0 and solve it. Set the bottom equal to 0 and solve it. Set the bottom equal to 0 and solve it. You do need to check the top, because if the top cancels with something on the bottom, then that was a hole, not an asymptote. Horizontal are all your rules, which you need to know. Okay, so I'm going to factor the top just to be careful. Add to give me 2. Okay, that works. And the bottom. And nothing cancels. So now I'm not interested in factoring the top at all. Nothing cancels. There are no holes. My asymptotes are going to be x equals -4 and x equals 1. X equals -4 and x equals 1. No, he's a -1, so he's out. There's an x equals 1. No. So it's got to be D. But let's review the horizontal asymptote rules just to make sure you're good. You look at your degree, which is the highest power. If they are the same, it's y equals a over b. A is the leading coefficient of the top. B is the leading coefficient of the bottom. So this is 1 over 1, so he's y equals 1. If you had x squared over x cubed, if the bottom degree is bigger, it's y equals 0 no matter what. If the top degree is bigger, then there are none. And that's on that things to remember study guide that you're supposed to stare at. So that's 77. Now we're going to go to 79. What value of h is needed to complete the square? Okay. Half of 10 is 5 squared is 25. Balance it out. And it wants h. Now that's a 5, but that's x minus h, so that would need to be a -5 to make this a plus. Okay, that was 79. Now we're going to go 81, which is another asymptote. Vertical, set the bottom equal to 0 and solve it. I want a -1, so I want a -3. So x equals a -1/3 and a +1/2. I need to factor the top just to make sure there are no holes. And nothing cancels. Almost, but no. So I get to keep both of these. X equals a -1/3 and a +1/2. Okay, now we're going to do 82. Okay, here's another distance. Now, the last time we did a distance, it was really easy, but this is a distance between 2 points, so you have to know your distance formula. All right, I need the points where these two lines cross. So I'm going to my calculator, and I'm going to type in the absolute value of x minus 3. And I'm going to type in, is that a 1/2 x? And then I'm going to go graph. And there they are. Okay, now here I go. I don't have to hit trace. You can go exact. Go second calc and go intersect. And it wants me to get near where they intersect. On the first curve, I hit enter. It jumps to the second curve. I hit enter. It wants me to guess. That's stupid. And it tells me exactly what it is. 2, 1. So there's the first point. And then I'm going to do it again. So I go back to second calc, go to number 5. I have to get over to the other point of intersection. First curve, yep, jumps to the second curve, and I don't want to guess. And what is that, 6, 3? So now, x minus x squared plus y minus y squared. 2 minus 6 is a negative 4, squared is 16. 1 minus 3 is a negative 2. Negative 2 squared is 4. 16 and 4 is 20. So the square root of 20. Could have made it 2 root 5, but they didn't. And they could have gone decimals, but they didn't. Okay, that was 82. Now we're going to go 84. 84 domain. Domain is x. All right, this guy, if you don't know what he looks like, graph him. But he looks like this. Domain. All right, now, if range was low to high, domain is left to right. Okay, so how far left does this guy go? He goes all the way to negative infinity. Negative infinity always gets a parentheses. And we go all the way to 2. Now, do you get to B2? Well, sure, I can do this. Negative 2 plus 2 is 0. Guys, I can square root of 0. I get a 0. If you graph this on your calculator, he may not go all the way down. He may not get that last little pixel. If you go to your table, it'll show you that at 2, your y value is 0. So you can go all the way to 2. He gets a bracket. And so I'm less than 2. And they wrote it old school instead of new school. Okay, that was 84. Now we're headed to 86, which is super easy. I got a limit. He has no issues whatsoever. I'm headed to 3. I mean, love that. 86. Now I'm going to 89. '89 is another piecewise, and I want f of negative 3. So that's going to be in here. He's going to the top one. So negative 3 squared plus 2 times negative 3. Positive 9, negative 9, minus 6, negative 15. Okay. 2 times f of negative 1. Negative 1 is going to be in here. So he's going into this one. So 2 times 1/3 to the negative 2. Flip it and square it. That'd be a 9. That'd be an 18. And then times it by the 2. That would be a 36. And then f of 4. 4 is going to be in here. So 2 times 4 minus 5 over 4 minus 7. 8 minus 5 is 3. Negative 3, so that's a negative 1. So plus plus, and that gives you 22. Now, that's not difficult, but there are 1,000 places in there for you to lose a negative or forget a negative or forget the 2. So just take your time and be careful. All right, that was 89. Now we're going to go to 90. Okay, I'm going to type all these into my y equals, and I'm going to go to my table, and I'm going to see which one heads to infinity the closest. Okay, I've got them all typed into my y equals. I'm pretty sure my table is jacked up. I'm going to start at 0, and we'll go by ones, and we'll just check it out. I want to know who's getting large the fastest. Okay, I think it's between the two purple ones. The Y2, the one that I'm on, 8.89 e to the 6th, and the other one's 2.94 e to the 7th. So right now Y4 is winning, but if I keep going, and you can always take your table set and jump to like 50 and see where they are then. Okay, and then you can really easily tell that Y2 is winning because that's times 10 to the 22nd, and Y to the 4 is times 10 to the 9th. So Y2 wins. So Y to the 4th looked like it was winning early on, but you need to stretch it on out there and see what it does as you're truly headed towards infinity. And I'm just at 50, and Y2 is the definite winner. Okay, and then the last one, 92. Solution. So you can cross multiply, or you can get a common denominator and then drop it. I'm going to get a common denominator. So he needs a 4x plus 5, and he needs an x minus 1. Then they both have the same denominator. So 8x squared minus 12x plus 10x minus 15. 8x squared minus 8x plus x minus 1. My 8x squareds are going to cancel, so I'm not quadratic anymore. If you're not quadratic, I don't want it equal to 0. I want the x's on one side and the numbers on the other. I'm going to clean this up and clean this up. And then I'm going to add 7x. And then I'm going to add my 15. And I'm getting 5x equals 14. And then I'm going to divide by 5 and get 14 over 5. And I don't have to worry about him making the denominator 0. That would be a 1, and that would be a negative 5/4. So I'm good. I get to keep it. Okay. So what I just did were all the problems on that 1 to 100 that had to do with functions and what had to do with limits. There's going to also be a video posted for series and sequences and parametric equations, and another one for logs and exponents and trig. Watch these to help you prepare for the final exam.